Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8086 microprocessor. Look at this. This is the architecture of 8086 microprocessor. So 8086 microprocessor consists of 16-bit bidirectional data bus and 20-bit address buses. So it can address 2 power 20 address lines, that is 1 megabyte, and it can capable of doing the 16-bit operations at a time. Look at this, it consists of two blocks. So left side, so this is an execution unit, and right side you have this BAU, that is bus interface unit. Look at this, this is the general purpose registers, and this is the ALU, and then we have the registers for the temporary registers and internal control systems, and this is the, we have address generation logics, segment registers, and then instruction queues. We can see detailedly. So first thing, so this is the actual segmentation. What is the need for segmentation means we have a 20 address lines. So 2 power 20 will be 1 megabyte. So 1 megabyte we cannot access continuously. So general purpose all registers will be 16-bit only. So due to this 16-bit, 2 power 16 address can be accessed, that is 64 kilobit alone accessed easily. So that's why we are going for a segmenting. So totally we are going to segment 4 segments. So we can configure based on our requirement. So the segments are, this is CS, that indicates a code segment, DS indicates a data segment, SS it indicates a stack segment, and then ES it indicates a extra segment. So the extra segment and data segment, that will be used for storing the datas, and code segment it will be used for storing a program codes, and SS stack segment that will be used for stack purposes. Whenever they are pushing a data, push or pop, so the data will be stored in the stack segments. So this is the address generation logic. So whenever you are accessing the data, so based on that next data should be incremented. So this address generation logic will take care of this. And instruction pointer, so this is used for a offset register. So whenever you are accessing the data, so the code segment register into hexadecimal 10 plus instruction pointer, it produces the 20-bit physical address. So remaining offset registers will be under control of execution unit. Only that instruction pointer, so this is used for accessing the particular program codes. So that's why code segment and instruction pointer to be combined to generate a particular location for a programs. So that's why this is in the under control of the bus interface unit. So the code segment, this is the base address, it should be multiplied with hexadecimal 10, and then that will be added with the instruction pointer. It produces a 20-bit physical address. So these physical address locations only accessed for the program codes. So once you have accessed, so next location the continuous program will be accessed. Here look at this, this is the internal communication registers. So this will be a bus control logics. The control signals will be generated by using this bus control logics. So this is the data bus, and this is instruction queue. So we know that queue is first in first out concept. So what is the need for queue means we have two execution units. So one is a BA unit and another one is a execution unit. So these two will be works in the fashion of pipeline concept. That is, the fetching instruction is in the BA unit, and then execution will be done by the execution unit. So these to be synchronized by using this queue. So the BA unit take the instruction from the memory, and then it fetches us and it's put it in the queues. So it continuously take the instructions, next instruction, and put it in the queues. So execution unit take the data from the instruction queue, and it decodes and start executing it. So the only fetching and giving the data is only the BA unit work, and then the execution and storing this will be taken care of this execution unit. Look at this, what are the blocks of execution unit? So this is ALU, arithmetic and logical operations. Arithmetic like addition, subtraction, multiplication, division, and logical operations like AND, OR, XOR, and NOT, and ones complement, twos complement. These to be done by this ALU unit. Look at this temporary registers. So this will be connected to this, and then flag register will be output of this. So whenever you are performing some operations, so based on that status, the flag register will be updated, like a carry flag, auxiliary carry flag, direction flags, sign flags, and then depending upon the conditions. So these flags will be updated in the flag register. We can see this format detailedly later. Look at this. This is an ALU data bus. This is a bidirectional 16-bit data bus. Look at this. This is the general purpose registers. So AX, BX, CX, DX. So this is a 16-bit register. Whenever we need to use, we can use it as a 16-bit register. Whenever we need to use an 8-bit register, we can split it into lower and higher. So if we take a lower and higher, AX can be split into AL and AH. So AL is a lower bit of AX register. AH is a higher bit of AX register. Similarly, BX, CX, DX can be split into 8 bits. So lower 8 bit will be called with this letter of L, and higher 8 bit will be called as a register with the H. Look at this. If you take a BX register, lower 8 bit will be BL and higher 8 bit will be BH. And this is SP, BP, DI, SI. So these will be used for an offset register. So SP is a stack pointer, BP is a base pointer, D is a destination index, SI is a source index. So these registers will be used as an offset registers for accessing the data. So for a data segment, extra segment, stack segments, these pointers will be used. So normally for a stack register, we use the stack pointer. So stack register SS, with this stack pointer, we get a physical address of stack register. Similarly, SIDI, whenever you are performing a string operation, we need to use this SIDI alone. And BP, so we can use it for any general purposes. So we can use it for a code that is data segment or extra segment. Even we can use it for a stack segment also. Look at this. So this temporary register, the purpose of this temporary register, whatever you are performing ALU operation, that particular data should be stored in this temporary register. After performing, again that will be stored to register, and then it will be moved to memories based on requirements. Look at this. These blocks will be a bus interface unit. So BU fetches the instructions, reads the data from the memory IO ports, and write data to the memory and IO ports. This is the functions of BAU unit. Look at this. So these blocks will be execution unit. Execution units instruction, it will be take the data from the queue and then it will be executes. So these two unit will be worked separately, and then these two will be work the fashion of pipelining concepts. Look at this. So this is the address generation logic. So dedicated address generated, it generates a 20-bit. That is a segment register into hexadecimal 10 plus offset register. Look at this 4 segment register. So code segment CS, data segment DS, stack segment SS, and extra segment ES. Look at the segment register detailing. Look at this. So we can map segments depending upon our requirements. Look at this. So segment 0 and segment 1, this is continuous. Continuous means at the end of the location, next segment will be started. There is no overlapping here. So this is the best way of using all the locations. Look at this. Segment 1 and segment 2. So these will be partially overlapped. Look at this. So these places 2 will be overlapped. So what happens if you overlap? If you write some data through this segment 1 and if you overwrite the data in through segment 2, what happens? The final return or a last return data will be available. The previous data will be removed or that will be overwritten. So the overlapping, so it can be allowed, but we should be very careful in the writing of programs. Look at this. This is segment 2 and segment 3 is a fully overlapped. That means entire locations of segment 2, that is a 64 kilobyte entire locations, will be overlapped with the segment 2 and segment 3. So we should be very careful whenever it will be overlapping. Look at this segment 2 and segment 4. These two will be a disjoint. So disjoint means there is no continuation. So because we have a 1 megabyte locations, so entire 1 megabyte can be used. Each segment we can only take a 64 kilobyte. So we can use it a disjoint. So wherever we location we can use this disjoint. Similar segments can be mapped into 2 different. So after using it, we can map to some other location. We can use that location also. Thank you.